Hello everyone, we are the CodeGirls TS team responsible for Camila, our capstone project for the Program 5 course. And our project is a hotel reservation system. Our team consisted of me, Milene, Caterini, and Laura. And before we dive into the technical part, we wanted to highlight what the system aims to solve. We defined 5 core objectives for Camila. And first, to ensure a secure user registration and login flow. Next, to provide an administrative area to create and manage hotels and rooms. The heart of the system is the third point, allowing customers to make reservations and simulate costs in real time. In addition, we implement the automatic application of promotions and, of course, ensure that all this information was securely persistent in MongoDB. To ensure we all deliver this system on time and with high quality, we didn't just focus on code but also on management. We adopted an agile approach inspired by Scrum, holding alignment meetings twice a week. We had highly collaborative workflow where all three of us acted as full stack developers. To organize all of this, we centralized our management in GitLab, actively using the issue boards to track tasks and control deliveries. On the back end, we built our API using the Next.js framework running in a Node.js environment, also utilizing TypeScript to maintain consistency. For the database, MongoDB gave us the flexibility needed to model our room in reservation documents. We adopted a modular architecture, clearly separating responsibilities, with the controllers handling HTTP routes. The service centralized all our business rules and data availability calculations, and the Mongoose schemas handle direct communication with the database. For the user interface, we choose the Angular framework, taking advantage of the strictness of TypeScript's static typing to avoid runtime errors. We built the interface based on a component-based architecture, meaning we divided the screen into small reusable parts, such as the booking card. And to ensure the screen doesn't freeze while fetching data, our communication with the backend API is done asynchronously through the service. And now I will hand it over to Caterini.
Talking about the repository organization and architecture, well, we use a multi-repo approach with one repository for the front end and one for the back end. And this choice makes each part independent and easier to maintain. The directory structure is clear. Modules, interface, controllers, and service are separated. And well, for code quality, we use TypeScript on both sides so that it stays consistent. And this organization shows professional maturity and helps the team work better together.
Now, I will demonstrate how one of the system functionalities works directly in the code, showing the complete flow between the front end and back end. The example I will use is the cancellation of a booking made by the user. On the front end, we use Angular with TypeScript, organizing the interface into reusable components. Here we have the booking card component, which represents an individual booking displayed to the user. This component receives the booking data through an input called booking, which follows the booking interface defined in the system. When the user decides to cancel the reservation, the onCancel method is executed. First, the system displays a confirmation message to prevent accidental cancellations. If the user confirms the component, emits an event called cancel clicked, sending the booking ID to the parent component. There is also an interface rule implemented in the canCancel method, which checks if there are at least 3 days before the check-in data following the system cancellation policy. This event is captured by the user booking component, which is responsible for managing the user's list of bookings. When the component is initialized, it calls the getting user booking method from the booking servers to retrieve the user's booking history from the API. The bookings are stored using Angular signals, which allow the interface to update automatically when the data changes. When the cancellation event is received, the handle cancel method is executed. This method calls the booking servers to send the cancellation request to the backend. If the operation is success, the booking state is updated locally to cancel it. If an error occurs, the system displays an appropriated message to the user. For example, when the cancellation policy no longer allows cancellating the reservation. Communication with the backend is centralized in the Angular service, which uses the HTTP client to send the HTTP request to the API. In this case, the booking service contains the method responsible for sending the cancellation request to the backend. In summary, the flow works as follows. The user interacts with the component on the front end. The component emits an event. The parent component calls a service responsible for communicating with the API. The backend receives the request through the controller, and the service executes the business logic and updates the booking in the database. This flow demonstrates how the system separates responsibilities between the user interface, API, communication, and business logic. In the booking service, we have the main business logic of the application. First, the system retrieves the booking from the database using the provided ID. Then, several validations are performed, checking if the booking exists, verifying that the booking belongs to the authenticated user, ensuring that the booking has not already been cancelled, verifying that there are more than 3 days before the check-in data. If any of these conditions are not met, the system throws appropriated exceptions such as not found exception, forbidden exception, or by the request exception. If all validations pass, the booking state is updated to cancelled, and the change is saved in the database. On the back end, we use Next.js, which organizes the application into controllers and steps. The bookings controller is responsible for receiving the HTTP requests related to the booking. The endpoint responsible for cancellation is the post bookings ID cancel. This route is protected by the JWT LT guard, ensuring that only authenticated users can cancel their bookings. When the request reaches the controller, it extracts the booking ID and the authenticated user's ID and then delegates the process to the booking service.
In conclusion, I want to share the challenge and future steps. So the hardest part was modeling run availability and solving road conflicts in Angular. And well, we solved this with better schema design and clear routing rules. And if we had 3 more months, we would add payment integration, advanced search filters, and user reviews. These features will make the project more complete and closer to a real world product. Thank you so much. That was our presentation.